are things other than real numbers. They're called imaginary numbers. We will not touch on that in algebra 1. You will in algebra 2. But real numbers, positive numbers, negative numbers, and 0. On the real number line is any number that you can plot. And surely you can plot any real number. Okay. I can do decimals. I can do fractions. I can do whole numbers, right? Seen the number line before? They're usually horizontal. Whatever you make as your little markings, they need to be consistent. So if you go by ones, you need to go by ones. If you go by twos, everything needs to be going by twos. If you go by a fraction like fourths, you need to have 3 little markings between the whole numbers. Negative numbers are less than 0. Positive numbers are greater than 0. 0, is it positive or negative? Neither. Neither, good. The term integers, a lot of definitions, you'll have those on your test, so you want to make sure you're paying close attention. Integers are negative numbers, 0, and positive numbers. They do not have decimals in them or fractions. Fractions that don't turn out to be whole numbers. So, definitions. We've got natural numbers. And if you've seen like a Venn diagram, you're going to have, I'm going to draw it onto this side of the board. You're going to have natural numbers. And those are numbers 1, 2, 3. They do not have decimals. And then you've got whole numbers. And the only difference from a whole number is that it has what? Does anybody see? What else does a whole number have that natural numbers don't? 0. So a whole number, or a natural number is a whole number. The only difference as a whole number is it has 0. Okay, we just talked about integers. What does it also have other than whole numbers and natural numbers? Negative numbers. Do they have decimals? No. So these have negative numbers also, and these are called integers. Okay, so I'm making a little target. Natural numbers are in the center, like the bullseye. Then whole numbers are wrapped around it, integers are wrapped around that. Now, rational numbers, what do they include that the integers don't? Decimals. And these have decimals. Okay. Now, there's something very specific about these decimals. These decimals either do 2 things. They do what? They either repeat or terminate. Does anybody know what terminate means? Stop. Terminate means get rid of, but in this case it means to stop. So an example would be like 0.25. Okay, it stops after the 0.5. 1/2 is the same as 0.5. The decimal stops. Repeating is like 1/3, and that is like 0.3. Keep on going. All right, 0.678, 678. It's got a repeating pattern, right? So these right here, in our bullseye, I'm going to put a little rectangular box. These are a type of real numbers. Now, there are other real numbers, but right now, that's all we're talking about. That's the only ones that fit in that group of rational numbers. Okay, so let's play this little game. We are looking at these numbers below and determining if they are integers or not integers. So integers are what? Does anybody remember what they are? Whole numbers, negative numbers, and is that it? And 0. Good. What else? Or so 9. Would it be an integer or not an integer? How about -3? How about 10 11ths? Good. All right, how about 12 fifths? All right, how about 6? How about 8, -8? Okay, so what do you notice in the pattern here? How about negative 2.365? Good. Not integer. All right, so what's the pattern here? What makes it an integer? Whole numbers, negative numbers, 0. Okay, whole numbers is considered with the 0. Now, a lot of times in our brain, we think of whole numbers as numbers without decimals. Just realize that's not actually the math term for it, so just beware. All right, checkpoint. Which of the following, this is not on your notes, which of the following sets of numbers belong to the set of integers? In other words, repeating it. I'm looking at these different number sets, A, B, C, and D. And I'm looking to see which numbers in them all are integers. She says C. Does anybody disagree? Do they agree with her? I got 3 people. Awesome. They're right. Well, good? Questions? Rational numbers include integers, terminating and repeating decimals. Is that true or false? One person? True? Anybody agree? 2? Anybody disagree? Sure. All right, so there's a graph. Graph of a number line is different from graph of a coordinate plane. So when you're graphing, and that should be point, that corresponds to a number. All right, you want to plot that point and label it. Okay, plot it means if I'm asking you to plot 1/2. Okay, I'm going to draw my number line on a straight line on your paper. It's going to be between 0 and 1, and I can put a marking here halfway between, and that's going to be 1/2. Okay, got to label it. Put your point. The origin is 0. It's always 0 in any coordinate plane or number line that you talk about. And opposites. 2 points on a number line that are the same distance from the origin. Okay, same distance from 0, but on opposite sides of it. So what would be the opposite of 3? Negative 3. What's the opposite of negative 5? 5. Is that all right? Same distance from the number line. Same distance from 0. Negative 5 is how far away from 0? 5. 5 is how far away from 0? 5. Okay, distance has to be positive, and that's key. All right, same distance. So I want to plot the number negative 1 3/4. Now, it might be easier. If you don't know what 3/4 is, what is it in decimal? 0.75. Very good. So negative 1.75. Now, looking at the number line, look from 0 to your left. It looks like the numbers are getting bigger, right? But they actually mean they're smaller. These are smaller numbers to the left. All right? And to the right of 0 are your larger numbers. Now, the tricky part is when we start dealing with negatives, people get confused on them because they think, oh, negative 3/4 should be closer to 0 than to the negative 2. Which should it be? Would negative 3/4 be between negative 1 and negative 2 or negative 1 and 0? Right. Negative 1 3/4 should be between the negative 1 and negative 2. Now, would it be closer to the negative 2 or the negative 1? Negative 2. Because a fourth would be right here, right? And a half, then 3/4. So make your point, make a circle, and make sure you bring and label that point. All right, 2.7 be between what two numbers? 2 and 3. Good, and closer to 3. Thank you. But a little bit more than halfway, right? But closer to the 3. Don't get confused with decimals and fractions. Take your time, break them apart. Fractions are just division. If you're not sure, you can do the old school division and figure out what the decimal is. Now I want to write the following numbers in increasing order. What's increasing mean? getting larger. So I'm going to start with the smallest number and move to the largest. Now, what's my smallest number? Would it be negatives or positives?
Negative.
Negative. So I'm looking at the negative one. So here's a negative one, here's a negative one, here's a negative one. Which one's the smallest? -3. Remember, even though it looks larger, negatives are actually smaller. All right, -3. Then what? -1.5. Then what? -1. And then 0. Then what? Okay, so I've got these left. 1/3. That's -1.5. So then we got a 2.5. Now let's check our stuff. We have 1, 2, 3, 4, 5, 6 numbers. My answer should have 6. 1, 2, 3, 4, 5, 6. The biggest problem people make on doing these problems is they leave a number out. Make sure you check your stuff. Make sure you have 6 answers if you had 6 to start with. Right. Just be careful, because if you miss one, I have to count it wrong. Inequalities. We're going to ask you in your homework to write inequalities. You need to know that when it opens up, whatever's in front, whatever number is greater than whatever's behind it. And this less than, whatever's in front of the less than, is that number is less than whatever's behind it, to the right of it. And then we have greater than or equal to or less than or equal to. Now I'm going to ask you in your homework, write 2 inequalities that compare -1/2 and -3/2. So we're comparing them. We're writing 2 inequalities. What you need to do is write it the way you see it, -1/2 and -3/2. Which one is -1/2? Is it greater than or less than? Okay, he says greater. All right, think about it. -3/2 is -1.5. Remember, even though it looks like a bigger number, negatives are actually smaller. So he's correct. And then all you have to do over here is flip it around. -3/2 is blank -1/2. Is it greater than or less than? Less than. It should have looked exactly the same except everything's flipped. The numbers are flipped in different locations. The sign is flipped in the opposite direction. Is that good? 2 inequalities really quickly. All right, so I'm going to compare the letters of the alphabet using the inequality symbols. H and B. H and B. Is H less than or greater than B? It's less than. There you go. All right, D and A. D and A. Is D greater than or less than A? It is greater than. All right, G and H. G is greater than or less than H? Less than. If it's on the left-hand side of whatever you're comparing it to, it's less. It's smaller. Is that okay? All right, absolute value. This is the one that tricks people. Be careful. Absolute value is the distance between the origin and the point representing the real number. Okay? You'll use a symbol. For example, I did the absolute value, those straight lines, of A. I just made it some variable. And it represents the absolute value of a number, whatever that number is, A, X, 2, 3. It could be any number. So let's go over here to the side. If I do the absolute value of 3, that's the distance from 0 to 3. How far is that? 3. All right, what if I do the absolute value of -4? The distance from 0 to -4. How far is that? 4. All right, your answer will always be positive, always, if you just have the absolute value equal to something. The distance, and distance is always positive. All right, and this one's a little harder because we're dealing with a number line. We're looking for the length, even though it's misspelled, the length of BE. So I'm looking for the distance between B to E. That's all I care about. Now here's the deal. You need to know what each marking means. Does each marking mean 1 unit? It doesn't mean 1. Does it mean a half? Because look, from 0 to -1, how many markings do you have? You have 2 in between them. So let's look at the whole one. That's a little easier to see. We have 1 marking, right? 2 markings, and then the next one is a 3rd marking. So 3 over 3 makes a whole, right? So what's this one going to be? 1/3. All right, so E is located at 1/3. So B is located at what? The negative, right? And it's between the 1 and the -2. There's negative 1 and 1/3, and then there's -1 and 2/3. A little tricky, isn't it? They can be, so beware. That's a good ACT kind of question. You've got to look at the markings, determine what they mean ahead of time. All right, so does anybody know how to find the distance between 2 numbers that are away from 0? You could count them. What else could you do? Anybody know? Want to take a guess? It's okay to be wrong. What operation do you think you would use in order to find the distance between 2 numbers? All right. Subtraction. All right, and the reason that I'm doing absolute value of this is because I'm finding the distance, and distance always has to be positive, right? No matter what the numbers are, whether we're dealing with negative numbers or positive numbers or both, distance has to be positive. So do -1 and 2/3 minus the positive 1/3. All right. It's the same as saying this too, right? A lot of you were taught this way. When you minus 1, it's the same as saying plus a negative, right? I don't teach it that way, but sometimes that registers with you a little bit better. Plus a negative. All right, now what do you do when you have the same signs? You've got whole numbers and you've got fractions. Break them apart. 2/3 and 1/3. How many what's that make? A whole. So you've got your absolute value of -1 minus the whole that you just made, 2/3 and 1/3. What's -1 minus 1? 0. Oh, no. -1 minus 1. So same as saying -1 plus a -1. -2. Absolute value of -2 is 2. Distance from 0 to -2 is 2. Now, if you are giving a graph, a line graph, we just determined that each one of these means a third, right? So 1/3, 2/3, 3/3, that's a whole. 1/3, 2/3, 3 wholes, that's a whole. And you can add them, and that's going to be 2. Not always are they that easy, but you're more than welcome to use that method also. All right, the number of units or distance between an integer and 0 is called the absolute value. All right, how many units away from 0 is -10? Anybody? How far is -10 from 0? 10. All right, how far is 0 from +10? 10. Now, there are 2 markings. Guess what units they went by? 5. So beware of that. You'll want to pay close attention to your markings. Now, my program did not pick up the absolute values. All right, so the absolute value of 10 is 10, and the absolute value of -10 is 10. So it brings me to this. Values are always positive because why? You may think of why? Why is absolute value always positive? What if I'm driving my car and I put it in reverse and I back out of the driveway? Did I go a distance? Is it negative? No, but it's gone backwards. No, right? Distance has to be positive because it's a unit of measurement. Okay, measurement always has to be positive. You can't have a negative measurement. I can take things away, or I can go in a different direction, but yet it's still got to be a positive number. All right, so absolute value of 2. The distance from 0 to 2 is 2. Absolute value of -2. The distance from 0 to -2 is 2. Now, why is this one -2?
Because the absolute values are inside of the negative.
Good. She said because the absolute value of 2 is 2, right? But then what do I have on the outside? And I brought down my negative. That's where I got the negative 2. When you do absolute values, you're going to do those first like you would parentheses. So the absolute value of negative 6 is 6. And then there may be something else on the end, minus 2. Well, what would you do then? 6 minus 2, which gives you 4. Does that help? You're going to treat parentheses or absolute value like parentheses. All right, here's the tricky part. Some number, the absolute value of some number is 4.3. Can you think of what number that is?
Negative 4.3.
Ooh, I heard 2 different answers. Somebody said 4.3 and somebody said negative 4.3. Who's right? Who's right? Which one of these is right? Which one is the distance of 4.3 from 0? First one? First one? They're both right. You have to have 2 answers. Okay. Focus, focus. Very good. Very observant. I'm going to try to trick you and make you think on your own, so make sure you're with me. Somebody said negative 4.3, and they were right, but then they second-guessed themselves. All right? 4.3, the distance from 0 to that 4.3. Okay? It can be both positive and negative. So you'll always have 2 answers if there's a variable inside your absolute value. You with me? You'll always have 2 answers if there's a variable inside your absolute value. So B, what's the distance, what number is 3/4 away from 0? What can X be if it's a distance of 3/4 from 0? Negative 3/4 or positive 3/4. You must have both answers to be correct. Is that okay? All right, some of you are with me. All right. So here's the deal. When you're solving absolute values, you need to make sure the absolute value is by itself on the equal sign. If you're doing expressions, not a big deal. Just solve it, simplify it. But if you're doing an equation, absolute value of negative 3 is going to be 3. Absolute value of 4 will be 4. If the negative's on the outside, then your answer is going to be negative. Questions?